Hello, I am Ángeles Mendoza. In this presentation, we will review how policy guides the evaluation of Eflows in impact assessment and the mitigation of impacts on flow regimes. The objective for this lesson is to describe key considerations for the inclusion of Eflows in impact assessment, including mitigation of impacts. Impact assessment at project or strategic level is a tool to assess how proposed developments may affect river systems. Once the impacts are identified, there is need to propose measures to mitigate the changes in flow regimes and the related environmental and social components. However, the assessment is not enough if the mitigations are not implemented and evaluated. The impact assessment process has basic steps that apply to strategic and project level. For Eflows, the purpose is to determine how significant the changes on Eflows will be, how these changes will affect biodiversity, ecosystem services, and human communities that depend on them, also on water users. And finally, to decide how the impacts can be avoided or mitigated. We will not cover the whole process, but just mention key points for the steps in the process that are also relevant for Eflows. In the graphic, you can see that each step has questions that should be answered in the assessment report. The purpose of screening, the first step, is to determine if an EIA is required. Most countries have environmental laws and regulations that specify the type of assessment required based on the type and size of the project or the severity of the impacts that are expected. For small projects, the assessment sometimes might be just like checklists that include already known mitigations. For large projects, the assessments usually are comprehensive studies that need to be carried out by multidisciplinary teams. For your report, check in the legislation what types of assessments are required when impacts of river flows are expected. Stakeholders, especially potentially affected communities, should be involved through all the process. In scoping, they can comment on the terms of reference and express their concerns about the report. These concerns should be included in the assessment. During the analysis, stakeholders can provide information to know how they could be affected by the project. During the review step, stakeholders can comment on the results of the assessment and also indicate if they support or oppose the project, for example, in public hearings. If the project is approved, stakeholders can participate in monitoring and evaluation of the mitigation measures. Scoping is deciding what will be included in the assessment. In Unit 4, we reviewed how international policy for Eflows influences national policy and regulation. An example is the Water Framework Directive in the European Union. To comply with the directive, the guidance on ecological Eflows sets some principles for assessing hydrological pressures and impacts. It also includes a summary of methodologies to assess Eflows and suggestions for monitoring and evaluation of mitigations. You have reviewed the legislation that is relevant for your case study. A suggestion for your report is to discuss in which way that policy or regulation sets principles or requirements to assess Eflows during the assessment process. Are there goals or principles? Are prescribed In developing and transition countries, the environmental and social policies of donors set the expectations for what should be included in impact assessment reports when proposed developments may affect water resources. We will review two examples. In 1995, the Asian Development Bank started to adopt safeguards to control the environmental and social risks of its investments. In 2009, the bank compiled the three safeguards in a single document that is compatible with the Equator principles that also other banks follow to assess risks. The safeguards of the Asian Development Bank do not require explicitly to maintain Eflows. Although in principle, Eflows are indirectly covered by asking project proponents to address transboundary impacts on international river systems, to avoid as much as possible significant changes in natural and critical habitats, and to aim for no net loss of biodiversity. The Good Practice Sourcebook for the bank's environmental safeguards mentions that data may be needed for extended time, especially when there are seasonally variable elements such as river flows. But also it specifies that if the ideal collection period exceeds the time for the impact assessment, then the collection can continue after the project has been implemented. Specific mentions for river flows relate to the impacts on livelihood that will result from the reduction on fish populations. Also, to the decrease on water flows in watersheds that are caused by the cumulative effects of multiple withdrawals. The second example is the International Finance Corporation. In 2012, it published an updated version of its sustainability policy. This policy seeks to improve the positive outcomes of investments and reducing the risks associated to projects it funds, directly or indirectly. The policy consists of 8 performance standards that guide the preparation of impact assessments. The standards in bold apply directly to Eflows. Standard 1 on assessing and management of environmental and social risks specifies, like the Asian Development Bank, the need to consider transboundary impacts on international waterways and cumulative effects of multiple extractions. It also mentions the need to analyze changes in sediment loads, interference with migratory routes, and increased pressures on the current capacity of ecosystems that might affect the survival of indicator species. Standard 3 on resource efficiency calls for alternatives such as modifying projects when their water consumption negatively affects the ability of other parties to get water. Standard 4 on community health, safety and security specifies 2 situations that need attention to avoid increasing the risk of natural disasters affecting communities. For example, analyze how changes in vegetation types that mitigate natural hazards, such as wetlands, forests, and mangroves, will increase risks. Also, to assess the degradation in quality and quantity of surface and groundwater and other changes that might worsen the impacts of climate change, especially on priority ecosystem services. Standard 6 calls for analyzing alternatives to avoid impacts on biodiversity. It suggests to use an ecosystem approach to understand the interactions of the project with the environment. The standard also emphasizes to manage ecosystem services and protection of critical habitats based on 5 criteria. Critical endangered species, endemic or restricted species, migratory species, highly threatened or unique ecosystems, and key evolutionary processes. In the assessment process, it's important to analyze alternatives, to explore other ways to meet the need behind the project. This with less impacts and possibly with more benefits. Alternatives should be considered during project design, through the assessment process, and along the life cycle of the project. The performance sheets suggest alternatives that apply to Eflows. For example, variations in the layout of project facilities, use alternative engineering and manufacturing processes, modify construction practices to respect timings for ecological processes such as breeding or migrations, selection of different sites or routes to avoid disturbance, consider modifications that may affect drainage systems, consider changes to how the vegetation will be cleared or disturbed, and put controls on erosion and sediment flows. The analysis of impacts involves deciding how significant the alterations of flow regimes will be. Preferably, significance should be based on social values and technical aspects, including hydrological and ecological characteristics. Biological indicators and monitoring data should be used, especially for indicators that are sensitive to hydrological alterations. This will tell the extent of impacts on biological and human communities. Often, significance is influenced by political and social values that guide the definition of the desired conditions for river systems and ecosystems. When there is not enough data or the regulation is very restrictive, sometimes the significant thresholds might be reduced to a single value, for example, the 10% of the annual average runoff. International financing organizations endorse the application of the mitigation hierarchy as a goal and best practice for impact assessment. This implies first to do what is possible to avoid causing significant impacts. If this is not possible, then a second option could be to set mitigations to reduce those impacts. When that is not possible, then the next option is to repair the damage that occurs. And lastly, to compensate when restoring the damage or the impacts is not possible. The hierarchy also encourages to seek options to enhance the condition of the environment, to try also to, for instance, improve the provision or supply of ecosystem services. It is important that the mitigations that are proposed to control the impacts are also assessed, because if they will result in additional impacts, probably they are not good mitigations. But if there are no other options, then it's important to also mitigate those impacts that the mitigations could cause. Applying the mitigation hierarchy is more a political than a technical process. When the assessment of Eflows especially considers ecosystem services, it will provide information for stakeholders that they can use to negotiate the desired conditions for the rivers or to decide what would be the appropriate compensation for impacts that cannot be remediated. Most regulations or standards will call for avoiding impacts on inflows, but also they might include exceptions. For example, the Standard 4 of the International Finance Corporation specifies that alternative sites should be selected for projects if it is not technically feasible to mitigate adverse impacts, or the cost of doing that will be excessive. However, it also indicates that in some conditions, water abstractions could be above the recharge rate. The Asian Development Bank indicates that in some cases, impacts are allowed if there are no other alternatives to the project. After the project is approved, follow-up is the implementation step in the assessment process. National and local regulations will specify what entities are responsible for ensuring that the mitigations are implemented and evaluated to verify if they are effective in controlling the impacts. In most cases, the proponents are responsible for monitoring and reporting, and public officials conduct inspections or audits to verify compliance. The proponent might contract a third party to do the monitoring and report on the findings. The purpose of follow-up is more than monitoring, is to use data for adaptive management to adjust mitigations if it is needed and verify that no unforeseen impacts are left unattended. This is important especially when there is uncertainty about the environmental impacts, the technology that is used, or the effectiveness of mitigations. In many cases, the responses of organisms are not known, so we cannot really predict how they will respond when the environment changes. The main instrument to verify compliance is the Environmental Management Plan. The minimum elements of an environmental management plan are defined in guidance or regulations. Donor organizations such as the International Finance Corporation and the Asian Development Bank have documents that specify what is required in the environmental management plan. This is basically a document that will include a detailed description of the environmental and social components that the project will affect, the anticipated impacts, the mitigations for each impact, the roles and responsibilities for implementing the mitigations, provisions for monitoring and reporting, and procedures and schedules of when different activities will take place. Often, these plans will include the cost and sources of funds to implement the plan, and finally, performance indicators to evaluate the effectiveness of the implementation. This table illustrates the elements of an environmental management plan. The example is from the EIA of the Guizhou High Efficiency Water Demonstration Project in China. This project was financed by the Asian Development Bank. The project involved the construction of 2 dams on the Pingyao River and the Ganjiang River, both within the Luohu River basin. The purpose of the project was to improve the livelihood of people living in degraded areas in the Anlong and Nayong counties. The project consisted in increasing water availability to develop agriculture and revegetate degraded lands with fruit trees. The plan assigns to the Reservoir Management Authority the responsibility for maintaining Eflows. Considering the absence of the endangered species downstream of the dam, the Eflows were set as 10% of the average yearly flow of the river based on national requirements in regulations.
Take-home messages. Impact assessment is a tool to analyze the changes that proposed developments might have on flow regimes and the associated ecosystem services and biodiversity, and communities that depend on them. Impact assessment integrates different hydrological, ecological, and holistic methods for assessing Eflows. However, in practice, the assessment method might be limited by budgets, availability of data, or time set for the impact assessment process. It is important to consider the cumulative effects of multiple activities on Eflows and ecosystems. Finally, the Environmental Management Plan is a key tool for implementing mitigations when projects might affect flow regimes. By assigning responsibilities and setting performance indicators, these plans become accountability tools.
Read the presentation notes and additional readings to get more information. Thank you very much.